So let's talk about some characteristics of logarithmic functions, okay? So the domain for a log function is going to be positive non-zero numbers, or from 0, open, so not including 0, to infinity. The range is all real numbers, or negative infinity to infinity. Now, one thing to note is this is the exact switch from the exponential graphs domain and range that we saw when we talked about exponential properties. And that is, again, because exponentials and logs are inverses of each other. And so if you switch the x's and y's, then you're also switching the domains and the ranges. Now, every graph is going to pass through the point 1, 0. Now, again, that is an exact switch of the 0, 1 ordered pair that we utilize in the exponential graph, but it also ties back into that property of log base b of 1 is 0. So we have 1, 0. Now, if your base is bigger than 1, then it increases as you go to the right. Okay, so I'm going to pull the graph back up. Here is our log base 2. Notice that that is going up and to the right when we have that, okay? Now, if the base is between 0 and 1, then it decreases. Now, these are the same statements that we have. It's just that the graph shape is a little different here as far as where the directional is. So here's that base between 0 and 1, and notice that it does decrease as we're headed to the right-hand side. Now, the graph approaches but never touches the y-axis, so it does have a vertical asymptote at x equals 0. Now, if you'll notice here, when we did the one about exponentials, there were 6 attributes or 6 characteristics on that one. It discussed that the exponential function was 1 to 1 and had an inverse that was also a function. This is the inverse function, so we're not going to talk about the inverse of an inverse. Okay, so that's the only one that they left off. Now, we also want to talk about transformations. Okay, now the thing with transformations on log graphs is that if they want a set of parentheses on here, so if they want to do a horizontal movement, a horizontal shift, then they have to put the parentheses on here. If there is not a set of parentheses, it is not meant to have a set of parentheses, and anything that you see is meant to be at the back, like you see here with the vertical shift. So if you have your log base x, and then they just put +7, then that is up 7. Period, end of story, end of discussion. Minus will be down. If they have a set of parentheses, again, it's the opposite of what we think. Plus is left, minus is right. Reflections, negative out front is still reflecting over the x-axis. That's up to down. Here's the concern, and I talked about a concern with this when we had it in the exponential, because we cannot have that negative base. In logs, we said that we cannot take the log of a negative. So we have to make sure that if they put log of negative x, we understand that they are doing a reflection there, and that we should only see this when they're doing reflections, okay? That is going to reflect it over the y-axis, so side to side. Vertical stretches and shrinks will still be done in the front. Things bigger than 1, stretch them. Things between 0 and 1, shrink them. Horizontally is going to be done again inside the x, and it will again be the opposite of what you think it's supposed to be. So they ask us to find the domain of log base 4 of x minus 5. Now, first thing that we're going to do is we're actually going to graph this lovely thing first, so that we can then handle and discuss finding the domain, because graphs can oftentimes help with this. Okay, so now then, same way that we did with our exponentials, I'm going to talk about a couple of key points. Okay, so I'm going to be utilizing 1, 0, okay, because they already told us that is a point. Now, that is the switch of that 0, 1. Now, I'm also going to use base, comma 1. Remember, I used 1 base on the other one. So in this case, I'm going to be using 4, comma 1 as my ordered pairs. So 1, 2, 3, 4, 1. Okay, so those again, I'm using my little X's here just to indicate where they were, and then I'm going to move it. Okay, so now let's talk about movement for this. I'm inside my set of parentheses, so that means I'm right and left. It's going to do the opposite of what I think. So minus, I normally think this way. It's actually going to go that way. So this is going to be right 5. So I'm going to come up here and I'm going to move right 5. 1, 2, 3, 4, 5. So the blue dot is going to be one that I use. 1, 2, 3, 4, 5. Now, we also have vertical asymptote. Okay? That vertical asymptote was sitting right here on the x-axis. Okay, so it's got to also move. 1, 2, 3, 4, 5. Okay, so here is my new vertical asymptote. So I'm going to go ahead and draw it in. Now, my graph, these two dots look like they're going kind of up a hill that way. Okay, so I'm going to arch them up a hill that way. And then I know that I have to have a taper tail against that asymptote. So I'm going to drag my taper tail this way. So there is my basic graph shape. Now, once I utilize this, I can see that my domain is everything on this side of the vertical asymptote. So my domain would be at 1, 2, 3, 4, 5. So it's to the right of 5, and then it's headed out towards infinity. So there is my domain for that particular graph shape.